Good morning everyone. In the previous lectures, we have taken numericals based on the work done by the block or by the forces when the block was resting on an horizontal plane and an inclined plane. Now today we are going to see numericals in which the block is resting on an inclined plane but it is going to strike the spring. So we are going to consider the work done by the spring force today. So the problems of work done by spring force, there are three possibilities which can be asked to find out. Let us consider a block which is resting on an inclined plane having a weight W. Now this is the spring that you can see here. This portion is called as post or buffer, or it is called as post, P-O-S-T, post, or buffer, B-U-F-F-E-R. There is a block which is resting on an inclined plane at an angle of 30 degree, and the distance between the block and the post is equal to 1 meter. This is called as post. Now here the block is here. So here the velocity v1 will be equal to 0 because the block is initially going to start from this. Now the first thing that is asked to calculate in the problems of spring, work done by spring, is firstly velocity with which the block strikes this post. So initially the block will move with a velocity v1 which is equal to 0 and is going to strike this stationary post with certain velocity. So we have to find out this velocity v2. So that is the first part, velocity with which the block strikes the post. This is the first question which can be asked in the problem of work done by spring force. Second, when the block strikes this post or when the block comes in contact with this, there will be no compression, but as soon as the force goes on increasing, the spring will go on compressing. So we have to find out how much is the compression in the spring. We have to find out what is the maximum compression of the spring. So block was here, it will strike this, we have to find out velocity, and then after it strike this, there will be compression in the spring. We have to find out how much is the compression in the spring, maximum compression in the spring. Now the spring is compressed totally. So energy will be stored in the spring, and when this energy is released, what will happen is the block will again return to its, or the block will move a certain distance. So the third part is when the energy is released from the spring, how much is the distance the block moves. So in the problems of work done by spring force, we are supposed to calculate velocity with which the block strikes the post, first part. Second part is maximum compression of the spring, and third part is distance traveled by the block when the energy is released from the spring. So these are the three things that can be asked to find out. First is velocity, second is compression, and third is after it has totally compressed, energy will be stored and it will be moving apart. Energy will be released, so the block, the spring will undergo expansion and the block will move certain distance. We have to find out how much is the distance traveled by the block. So these are the three things. Now the variation that can be here is in the value of force of friction and the spring constant K. The work done by the spring force is given as half K into x1 square minus x2 square. So if we are considering this position 1, the compression of the spring is x1, and when it comes here again compression of the spring is x2. So work done by the spring force is half K x1 square minus x2 square irrespective of direction of motion of the block. If it is moving downwards or if it is moving upwards, still the force work done by the spring force will be equal to half K x1 square minus x2 square. So in the derivation it was half K minus half K x2 square minus x1 square. So we have taken the negative sign inside, that's why it has become x1 square minus x2 square. Now we'll take first numerical in which we are going to find out the compression of the spring. So the first numerical focuses on finding out the maximum compression of the spring, and as we take the numericals, I'll tell you how the value of K is given differently and how instead of using the force of friction equal to mu times normal reaction, sometimes this value is given to us directly only. So how to use this value directly, that we will see. So let us take the first numerical on this. So the first numerical is a wagon weighing 450 Newton starts from this runs 3 meters down an inclined surface having slope 1 in 100 and strike a post as shown in figure. If the rolling resistance of the track is 5 newtons per kiloton, find the velocity of the wagon when it strikes the post. If the impact is to be cushioned by means of a buffer spring,